Today's lesson is about ratios and proportions. When we talk about ratios, we're talking about a comparison of two or more different quantities, two or more different numbers, using division. And it's a familiar concept from previous years of math. And in previous years of mathematics, you have learned that there's really three different ways to write the same ratio. Make a note of that. So saying 3 to 4, you're comparing the two quantities of 3 and 4 together, or 3 to 4, where the word 2 is symbolized with a colon, or the most common version, 3 over 4, and that's the one where it's really clear that we're comparing using division, because fraction bars really mean dividing one number by another. So question 1, a door is 75 inches tall and 35 inches wide. What is the ratio of the width of the door to the height of the door? So you can choose between your different methods of representing the ratio they're asking for, but I would recommend the fraction version, because when we use ratios to solve problems, the fraction version is one of your most useful. But what I want to point out is, however you format your answer, whether it's with the word 2, a colon, or a fraction bar, you have to be careful about the order you put your quantities, your numbers in, because they very specifically stated they want the ratio of width to height. In other words, width has to be before height, even if it's in a fraction, width before height. So if you take the width of 35 inches and put that first, and I'm choosing the fraction way of representing my ratio, and then you put the height in second, just a couple notes. You always want to check to see if your ratio simplifies. So if both 35 and 75 can divide by the same number, do that. And also notice how our ratio has, each part has units. Fun fact, and this is going to turn up a bit in your science classes as well. If you have the same units both above and below the fraction bar, they cancel out, kind of like having the same number divided by itself cancels out. So the units are gone if they match. And then you divide by 5 over 5, and you say the ratio of width to height is 7 to 15. Now, sometimes you have ratios in a word problem describing a geometric figure, which is why ratios matter in geometry. The measures of two complementary angles are in the ratio of 1 to 3. What are the measures of the angles themselves? A quick tip on word problems that have any sort of ratio, it actually really helps to take your ratio and rewrite it so that each part of the ratio has an x after it. Because when they say that you've got complementary angles in the ratio of 1 to 3, they really mean you've got two 90-degree angles, and when you simplify the relationship, one is 3 times as big as the other. So let's call the 1 a 1x and the 3 a 3x. So if they're saying the two angles are 1x and 3x, you know how to solve a complementary problem. You say they add up to equal 90 degrees. You finish solving for x. And then I want to point out they're not just asking what's x, or are asking what are the measures of both angles. Well, the 1x angle you already have an answer for, because 1x is just 1 times 22.5. What is the measure of the 3x angle? So in the end, the measures of your two angles are 22.5 degrees and 67.5 degrees. Now, at this point, we've talked about problems involving your basic ratios involving two quantities, two numbers, but from here on out, you're also going to see extended ratios. Extended ratios compare 3 or more quantities at once. For example, in question number 3, when you see this ratio 2 to 4 to 5. Question 3, the lengths of the sides of a triangle are in the extended ratio of 2 to 4 to 5. The perimeter of the triangle is 77 inches. What is the length of the longest side? Now, you can still, with extended ratios, use that trick for word problems where you put x after each part of your ratio. And if their claim is that the perimeter of the triangle with sides of 2x, 4x, and 5x is 77, it might help to draw that out. If perimeter is the distance around the outside of your figure, Then 77, the perimeter, is the total you get when you sum or add up the sides. You should get x equals 7. But reread the question sentence anytime you have a word problem. What is the length of the longest side? We're not done. How long is the longest side now that we know x equals 7? If you said the longest side was 5x, and if we plug in 7, we get 35, well done. Don't forget your units. All the other units were in inches, so are the units for our particular question here. Next, we're going to talk about proportions. A proportion is an equation involving two ratios. See how these are both ratios? They're both fractions. So if you have two ratios, two fractions that equal each other, that is called a proportion. And this is something you've worked with quite a lot in previous years of math, but it's been a while, so we're going to review. You are going to cross multiply to solve, but anytime part of your fraction involves a plus or minus sign, before you cross multiply, put it in parentheses. So when you cross multiply diagonally to solve your proportion, it would look like this: 6 times parentheses, or quantity, y plus 3, and then equals 12 times 5. Finish solving. You start by distributing the 6 to the y and to the 3, and then subtract 18 from both sides and divide by 6. Now, some of the proportions you solve don't have don't have a plus or minus sign involved, so they're more straightforward. Go ahead and solve 4b using cross multiplication. If you did 4 times x equals 3 times 10, you should get x equals 7.5. 4c is one step harder, because now you have two parts of a ratio that have plus or minus signs. Just a quick reminder, both of those will need parentheses, so both of them involve distributing when you cross multiply. So your first step might look like this: 2 times 3x plus 6 equals 5 times quantity to x minus 4, or the same thing backwards. Finish solving. When you distribute the 5 and the 2 and get all the x's on one side, and divide both sides by 4, you should get x equals 8. The last thing we need to talk about are the properties of proportions. These are the 3 rules about how you can change your proportion equation and still keep it true. So write down these 3 rules, and also write down the example proportion we'll use to show how this applies. First property of proportions is that your proportion is still true even if you flip the whole thing upside down. So if you flip 1/2 to 2 over 1, you flip 3 over 6 to 6 over 3. Do you see how both sides simplified it to 2? You still have 2 equals 2. It still is true, just like the initial problem where it would simplify to 1/2 and 1/2. Now the next one is interesting. Property 2 is that if you turn your head sideways and if you put the fraction bars here and here, it is still true. So if you write it as 2 over 6 equals 1 over 3, or if you turn your head the other way around and write it as 3 over 1 equals 6 over 2, it is still a true proportion. See how both sides simplify to 1/3. And the last rule is the most interesting. Your proportion, your equation is still true. It's still the same number in the end on both sides. If you take the denominator below the fraction bar and you add it to the numerator above for both ratios. So if I take the denominator and add it, the 2, and add it to the 1, if I take the 6 and add it to the 3, I have 3 over 2 equals 9 over 6. If you simplify 9 over 6 by dividing by 3 over 3, it matches the 3 over 2. It's still a true proportion. So see if you could use that set of properties to fill in the blanks in number 5. If you got that, if they started with x over 2, they must be turning their head sideways and putting the fraction mark here, so that if you do the same thing with the other part of the portion, it's 10 over z. If they started with 10 over x, they must have flipped the problem upside down, so it becomes z over 2 for the second fraction. And then for the last problem, they took the original proportion and they added the denominator to the numerator above the fraction bar. So if you do the same, if you added z above the fraction bar, it would look like this.